Okay, so for video 3, we're going to be taking what we did in video 2, which is where we pulled the data from the website. We're going to be taking that data and graphing it, and then we're going to graph it again against the Antoine model. So to start, we're going to do from plotly subplots. So we're going to do this, which makes it used to make a graph. So with the make subplots, we're also going to do import plotly as PIO. Oh wait, no, plotly.io as PIO. And then we're going to do PIO.templates equals plotly shift enter, and then we'll just do shift enter for all of these. Just make sure everything's working. And so then now we're going to do fig equals make subplots. And we're just going to do rows equal 1 and columns equal 1. Sure? Maybe? Yeah, okay. And now fig add scatter. And then for the x information, we want to do temperature, so we're going to do x equals t. And then for the y, we want to do the log of pressure, so log of PV. And then we're going to do, for the data points, we want to do the individual instead of a line. So we're going to do mode as markers. And then we're just going to name the line, we'll just do data. And then enter, and then fig update now. So this just changes how it looks. So we're going to do the height is 500, the width, let's go 750, and you can mess around and change this however you want, just to make it fit however you would like. And then we're going to name the x-axis title is, so we'll do t of x, and then we'll put the units of Kelvin. We'll just be K. And then we'll do the y-axis title as, we'll do log of P, and then we'll put that unit, which is pascals, so PA. And so then this creates the first graph, so then we'll do shift enter. And this has our graph right here. And so that's it right there. And you can see that it has this curve. So then now we have to do the Antoine equation. So define Antoine. And then, as we talked about in the first equation, or the first video, the equation we'll do that in the second line. But so first we're going to define it, Antoine, as we're going to do A, B, C, and then T. And then we're going to put a colon because we're going to do return. And then this is where we do the Antoine equation, which is A minus B divided by, in parentheses, C plus T. So that'll define it in the Antoine equation. So then shift enter. Now that's plugged in. So then we're going to do, the square root of error. So we're going to do define SQ error. And we're going to call it V. We're going to do temperature and then log of PV. Then we're going to do colon. And we do the model of PV equals Antoine, Antoine of, so we're going to do the error of 0, V of 1, 2, and then we're going to put temperature. I'm going to do sum squared error of np dot sum square that. And then we're going to return sum squared error. So what we've done here is we defined the square root of error, and we had used the values of v. So v was just like Antoine, it was whatever number it spit out. So v of 0, we plug that in, v of 1, v of 2, etc., temperature. And then sum squared error takes the calculated pressure and subtracts the data point pressures that we got from the website, and then we square it so that there's no negative values, all positive, and then we return that value. So the sum squared error calculates how far from the calculated data the data points are. So now we have to do some guesses. So we're going to do a guess equals, and we're going to guess 10. We're going to put a period after it because, oh, not bit length. Enter. So that way Colab knows that it's Colab knows it's going up to 10. So it knows that it's a number instead of a string. So we're going to do b guess, and I'm going to do 2000. And then we're going to do c guess equals 0. And then we're going to just do guess equals, and then we're going to do brackets a guess, b guess, and c guess. All right. So for the next step, we're going to have to minimize. So then we have to go up to the top. Okay. So now that we've gone back up to the top, we're going to do from sippy.optimize import minimize. And then we're also going to import jax, and then import jax.numpy as jnp. So what we've done here is we imported minimize function, which minimizes the sum squared error, and then we've also imported jax, which is a code that it deletes the roundoff error. So when it's paired with minimize, it will minimize errors in the graph. So we're gonna shift enter everything, just making sure that we're good to go, and then we also need to go up to where we did log PV here, I believe. Yeah, so sum squared error, we're going to do JNP, and then we're going to do res equals minimize the squared error, and then we're going to name it, we'll do x is 0, number lock was on, x of 0 equals the guess, and then our argument is that we have t, and then log pv, and then we're going to do jack equals jax error. So this is what's going to minimize our sub squared error, and then shift enter, and then we're just going to do, oop. Okay, so we had a couple errors just with equal signs, fixed all that, so it's good to go now. So then we'll do shift enter, and then it brings up this, which just gives us some information about the array. So yeah, we're good to go. Looking good. And then we're gonna pull up the actual graph. So we're gonna do team model, And we're doing T model because this is going to be how it's calculated through the Antoine equation. So T model NP of that lens space, and then so we're going to do T of 0, which is the first cell, to T, and then all the way to the end. So we're going to do -1, and then we're going to do, let's say, 500 data points, and then enter, and then we're going to do figure, add, scatter, and then we're going to do the X as T model. Last time we just did T, and then we're going to do the Y is equal to Antoine of the res of X0, the res, res of X1, and then res of X2, and then T mod. So that'll just plug it all into the Antoine equation and pull out the p-values, and then for the mode, instead of markers, we want it to be a full line, so we're going to do lines, and then we'll just name the data Antoine model. Should enter. And so this pulls up this graph, and as you can see, we've got all of our blue marker data points, and then our red Antoine model line, which corresponds perfectly with the data. You can see that all right here. All right. And so that is how to put that data into a regression model against the Antoine model.